Okay, so in this video we're going to do some review of derivatives, and what we need to remember is of course, our standard basic derivative rules for polynomials, but also, and exponentials and logs and trig, but also the most important thing I want to review is the product rule and the chain rule. So in this example, I have the natural log of a function inside here. So we usually call that u. And the rule for derivative of the natural log of u is 1 over that function u times the derivative of u. So I'm going to write du dx or u prime, right? I'm going to mix notations here, one way or the other or so. And go to skinnier handset. So using that rule in here, it becomes 1 over the 3x squared minus 3. And now I have to find the derivative of the u part, right? U was this. So now I have to multiply by the derivative of that, which is still a 6x. The derivative of 3x squared is 6x. The derivative of 3 is a constant, so it's 0. So it's like this. I'm writing like this just to be clear of the steps I've used. But of course, the final answer should be something like you put the 6x in the top, you put the 3x squared minus 3 in the bottom. And if this is a problem from a book, or you have an answer key or something, probably it would not show up like this, or probably you would factor a 3 from the top. Sorry, I said a 3 and I wrote a 2. So I'll factor a 3 from the top, so you get a 2x, and you factor a 3 from the bottom, and you get x squared minus 1, correct? So that way you can simplify or cancel those 3's, so your final answer should look like 2x over x squared minus 1. Okay, so that would be my final answer for this one. So yes, just don't forget that the derivative rule for the natural log does say it's 1 over u, but you have to multiply by this u prime. That's the important thing. Okay, second example would be this one, in which I have a product rule. Sorry, I want to do the next one. I don't want to show you the next one yet. So here I have a product rule and a chain rule. The chain rule is not that complicated. The product rule says something like, if you have the derivative of u times v, I'm going to write it in this notation now. It's the derivative of the first function times the second, plus the derivative of the second function times the first function. So here my first function is x squared. My second function is e to the 3x. And this is also, for this one, it's e to the u, right? Where the u is 3 to the x. So this one you have to remember that this is e to the u. And if you want to find the derivative of e to the u, this is just a chain rule. The derivative of this would be the e to the u, that's the derivative of an exponential function. But because of the chain rule, you have to multiply by u prime or du dx, okay? So in this case, the u prime would be a 3, because u is 3x plus 1. Okay, so I'm going to follow the product rule. So the derivative of my x squared function would be 2x times the function v. Sorry, here my function, this is my function u, that's my function v. So derivative of u would be 2x. And now the v, as it is, I don't take the derivative, so just e to the 3x plus 1. And now I'm following this product rule. So now it's plus the u function as it is, and now times the derivative of the v function. And that is what I said we're going to use this product, so this chain rule, sorry. So it becomes e to the 3x plus 1. And then you still have to multiply by this factor here. That was the derivative of 3x plus 1, which is just a 3, right? So again, you would not write it like this. This is correct, but if you leave it like this, it's not simplified. You can for sure write this like this. Put the 3x squared in front. And I forgot the one right here. And then you can see, sometimes you can also factor this. Why would you factor derivative 0? Sorry. You would need to know, well, this is 0. And you put the factors, so I can factor here, for example, x times e to the 3x plus 1. and the other factor could be 2 plus 3x. Right. So in this I'm just finding the derivative, so it doesn't make any sense a lot to factor it. But why would I want to factor it? Like I said, maybe if you want to find maximums and minimums, you want to find where this derivative is 0, and then you would need to find, then it's easy to see that this is 0 when the x is 0, this is 0 when 2 plus 3x is 0, so x would be negative 2/3. Right. Okay, my last example for this review is this one. So this is trigonometric function, the cosine, evaluated at x squared plus 1. So I also have a chain rule, and this is like a power rule. We call it sometimes a generalized power rule. When you have a function to a power, the derivative of that, the power comes down. It's the function u to the n minus 1. This is taken from just the derivative of this, right? Of x to the n is n times x to the n minus 1. But now it's not n, it's not x, it's a u. It's a u function. So again, the chain rule tells you you still need to multiply by the derivative of u. Okay, so this is going to happen here where my u is my cosine function. In this example, my u is my cosine function. So the derivative of the u is the negative sine of x, right? These are the pieces I'm going to need to do this. And then the u prime, sorry, I just told you wrong. This is correct. And then I have another chain rule, because this is not really u, right? This is really have something else going on here. I'm going to put a v here. And the derivative of u is not cosine of v, it's still times the derivative of v, right? So we have like 2 layers of chain rules. That just makes this one a little bit more interesting. So okay, let's go for it. So the derivative of h of x would be, the 3 comes down, cosine squared of x squared plus 1. This is this part. Right, I'm picking the n comes down, the power to the n minus 1. So I still need to find times the derivative of u. And my u is the function cosine. So I need to find the derivative of cosine and put it here. So I'm going to keep this here if you want a different color. This is going to be times the derivative of cosine, which is negative sine at x squared plus 1. And then, let me move this around a little bit. And then I still need to multiply by the v prime, where my v is x squared plus 1. So my dv, my derivative of the v, would be a 2x. Right, so I have 2 layers of the chain rule. Okay, so this is a bit more interesting here, what's happening. So I have, let's go again in pieces. I have my u function, which is the cosine. So the derivative of that would be 3 times cosine squared, still at the same, evaluated at the same place. But then times the derivative of the cosine. And the derivative of cosine is sine of this, but then I have another derivative of the insert function x squared part, which is a 2x. So derivative of this becomes, I should not leave it like that. Again, this is not simplified, so I should probably write negative 6x cosine squared of x squared plus 1 times sine of the x squared plus 1. So this is a derivative of the function we had. Okay, so this is a nested chain rule, and it's a review of basic derivative rules that hope we keep in mind for the rest of the quarter.